right, welcome back. This is chapter 10 in module 1, and we are getting started with 10.4. And again, you're going to see a quick progression from this using just chars to we talked about char arrays, which are also C strings. We're going to then now look a little bit more at some functions around C strings and then move right into strings, which is a much easier version or easier thing to work with when it comes to using strings. All right, so let's go ahead and jump in. So we've got some library functions for working with C strings. As typical, we would expect that you have to include a header file. In this case, it's C string, and the functions can take in different types of parameters. So we can take in the name of a C string, a pointer to a C string, and we can also just go ahead and straight and pass a literal. This is something that happens quite a bit, by the way. Some of those libraries, the functions in that library would be the string length, or strlen, and you're going to see that it returns a length of C string str. Here we have this size, which is some unknown number we don't have in here, and we've got the city name, and we output what the string length is, and it prints out 8. We also have the string cat, where we pass in 2 C strings. And it's important to understand that what happens is it appends string 2 to the end of str1. So this gets appended to this. Now, I know you're saying, Professor Waits, how does it do that? What if str1 isn't big enough to handle both str1 and str2? Uh, because, does it make it bigger? What happens? I'm so glad you asked. Because we can kind of take a look here at this little example I've put together to see what happens. So first, this city is exactly 8 characters long. So what happens when I try to take this and shove it into this without the 0 terminating piece? What happens? Well, let's go ahead and run this really quick and just see what happens. Takes a little bit of time to get going. Oh, initialize your string for an array of characters is too long. And the reason it's saying that, because even though this is exactly 8 characters, it knows that it needs that 0 terminator at the end, and 8 won't allow for it. So that's why it's causing that error. Now, how do I know that? Well, one way to do it is let's just add 1. So now we've added 9. And will everything work? So yes, as you can see, it went ahead and it did this piece, and it even outputted the length of the string. So, okay, so then what's happening here? Why are we getting this error? Which is a really good question. And the reason being is this is actually answering the next question we had, which is what happens when we take a string and we try to catenate something like this is 3 characters. Remember, again, we got the 0, the null terminator. And now we're trying to take that state and put it up against the city. The problem is the city is not big enough to handle this, and that's why this compiler is actually throwing this error, which is stack smashing detected. And different compilers will have different ways of explaining that error. But essentially, that's just saying, hey, you're hitting the bounds and going, we recognize that you're going over the bounds. Okay, well, then let's just make it 20. It should have And there you go. I didn't even add a space because, I'm looking to be quick. Oh, wait a second. Let's do this. Remember I said oftentimes we will use string literals. So space is a string literal. Oh, and then heck, let's even be all the way. So now we put that comma in the space, and then we put the state, and then we're good. All right. So now you know what happens when that first string is not big enough, or that first C string is not big enough to take in the second C string, all along with, and again, remember, it also still needs to have a space for a null terminator. A string copy. So string copy copies str2 to str1. And again, remember that yellow doesn't work too well on this background, does it? We still got yellow. All right, so that's fun. So the str2, str1 has to have enough available space for str to fit into it. Now, again, this is saying that the cat and copy do not perform bounds checking, and that is true. Some compilers and some systems that are running will be kind enough to at least give you the error as it's happening. In fact, our compiler did that. As the code was running, it recognized that there was what it called a smash, and gave us the error. But not all compilers will, and so keep in mind. And also, that check didn't occur until we were already running the code. So this definitely doesn't happen during compile time. We're not nothing's being checked in that. So a C string inside of a C string. So we have this str. String 1, string 2 finds the first occurrence of string 2 and string 1 and returns a pointer to match or null if no match. Pretty straightforward. Play with this a little bit. I don't want to spend too much time because, again, it's going to look for the first occurrence of that ABA inside of the river. Okay. And it returns. That's the other thing. This is a big difference from the other functions we were just working at, where the first parameter was kind of the target parameter. This actually outputs the information as a return. So in this, we've got the C string numeric conversion functions. We're not going to spend a whole lot of time on them. It's one of those things that I don't think that it's like this thing you got to memorize. You will over time just because you use them enough, and they're pretty straightforward. A to I, converts a string to an int. A to L converts a C string to a long. Then you've got A to F, which technically stands for float, but we're going to get a double value. And then we can go backwards. We can go I to A. So it's going to converts the first int parameter to a C string, stores it in the second parameter, and the third parameter is based on converted value. So play with this a little bit to get to understand, and again, here are the ints that are involved, or excuse me, the parameters that are involved. Play with that a little bit, get used to it, get familiar with it. Here's an example of those different pieces, including how the A to F is going to put this into a double. And then this takes the inum, which is 1, 2, 3, 4, tries to put it into the int char, and even I sometimes have to go back and look. Third parameter is base of converted value, so this is going to be base 10. Okay. Again, if C string contains no digits, results are undefined, and this again really comes down to what's going on at the time. Oftentimes, it can be relative to the system it's running on. It's not real. You're not going to be fully sure what's going to happen in this case. The function may return results up to the non-digits. It may just return zero. The IOA does not do balance checking. Again, make sure that this is enough space to store the results. You're going to get very familiar with this, especially in the lower level. The like I said, this I to A when you're dealing with G strings, it's pretty low level, so there's not a whole lot of checking that's done for you. String to number conversions. We're about to start talking about strings, and this is nothing more than a lot of these, but there's even more. And this has to do with converting strings. So this is string to int, string to long, and so forth and so on. So I don't want to go through all of these. Make sure you read these. Make sure you understand them. There is definitely probably going to be some on the test. The toString. So this accepts an int argument and returns the argument converted to a string value. So this was taking strings and going towards the numeric side of things, where this is taking a numeric value and going to the string side of things. And that's one of the nice things about C++ is because it's it's much more low level than a lot of your upper programming languages. You can definitely do a lot of your own stuff. Don't get me wrong, a lot of the upper languages do as well, but C++ is really strong in this area, and so you can write your own handling functions for your C strings. In designing C string handling functions, you can pass arrays to pointers to char arrays. You can perform the balance checking. Again, we know that most of the stuff that revolves around the C string does not do balance checking. You could write something to do some balance checking, and you can anticipate unexpected user input, which again, this is a must. You've got to start getting good at this as you go forward in your development, and even in this class, there are definitely going to be times where I'm going to expect that you're going to do some checking anticipation for unexpected user input. And if you don't, I'm going to have to take some points off your assignment, because you got to get good at just recognizing those typical things. Like if you're asking for a number, you better guarantee that some user is going to come along and try to put a letter in there, right? And that's just, maybe they fat fingered it, and that's the problem. Maybe they just didn't read the instructions. Who knows? But you need to be prepared for that. Here is a function that's been programmed to take in C strings and step through them. Again, I don't want to go too far into this. Make sure you take a look at this, and you should be able to walk away now and actually understand what this is doing, and have a high confidence that you can read this. If you're not, definitely review what we've been talking about so far, because should be pretty straightforward. And then we've got the name slicer. Again, another function that you can utilize to help along with your C strings. Now, I want to take a moment to talk about this program, because it is a pretty nifty program, and it actually takes advantage of the null terminator. So if we have an array of chars, remember, when we start using that array, the system itself, for the most part, starts to use that null terminator. So, in that case, if you purposely put a null terminator somewhere, it will all of a sudden truncate the rest of the C string. So in this case, what it's doing is it's saying, hey, you know what? Let's look for the first space, or the null terminator if there are no spaces, right? Because if there are no spaces, then it is what it is. The function is supposed to split the spaces. So again, that's the function looking for the expected odd stuff, right? That is, well, what if whoever uses me gives me a C string that has no spaces in it? Should I just crash? No, I'll at some point get to that null terminator and then just say, okay, well, this one's already split, so we can't split. So this is going to split on spaces. So if it goes through the loop and it finds a space, then what's going to happen is it's going to replace that space with a null terminator. And by doing that, array, so imagine here's uh, your array. And today I don't have my pen, so I'm doing this by the mouse. So actually, it's actually looking really good. So I'm quite pleased with my mouse skills. So again, if this had letters in it, this one did, and this one did, and this one did, this one did, but this is a space, and then more letters, and then the zero terminator. If we are doing this and we come up and we say, oh, this is a space, and then all of a sudden we replace this space with a null terminator, from here on out, when we use this C string to the system, it is now only this. It will forget all of that. Nifty little trick there. And this is a great little use, and you definitely will use it on occasion. So now we're going to kind of dive into the string class. And you're going to say, Professor Waits, why did we go through all of that when we could just have used the string class from the very beginning? And it's because that's the strength of C++, is that you can get to the much lower levels here in the programming language, and so you should know about those things. I will tell you that the C++ string does work rather differently than the C string behind the scenes. It's not really utilizing per se an array. There's actually a whole set of rules that it uses for memory management. But that's the point of the string class, is that you don't have to worry about it. It's going to handle the management of the memory for you behind the scenes. Now, whenever someone ever tells you that there's something handling the memory for you, always understand that usually means there's overhead. Sometimes it's a little bit of overhead, sometimes it's a lot of overhead. In this case, the overhead for the string class is pretty minimal. What I will tell you is, if you are going to use literals, you want to, and you're going to set it up as let's say, a constant variable. Use C string for that rather than the string. And the reason being is string has some overhead, and what you would see with a literal is it actually does a weird thing behind the scenes where it has to put it somewhere in memory and then copy it in memory. And it's just, while it would be milliseconds of our life, there's just a lot going on. And so when it comes to constant literals, we tend to want to use C strings. Just a little heads up on that. But again, if we want to use the string, familiar header, got to make sure we have that string in there. And then from there on, we can use strings. So again, we can define strings as first name, whatever the variable name we want, first name, last name. We can then assign values, and we don't have to worry about null terminators. We can display them using cout. Cout handles strings very nicely, and so very nicely, that's a great way of saying it. Quite nicely, how about that? And you can just out of the box start using that. So here's a program utilizing the string, and we want to make sure, here we are, we're going to include that header. We're going to set up a variable of string. We can then just assign something to it. Again, this is where oftentimes, if depending on what we're going to do with this movie title, if in our code this somehow, some way, kind of becomes just a literal constant, we would rethink this, right? We wouldn't want to do it this way. But more than likely, the movie title is going to change, depending on other places of the code, right? So it makes sense. So kind of pretend that in this code somewhere else that this movie title could change quite a bit. And so using a string is just fine here. And then, like we said, the cout works just fine with it. Our typical CN and cout work just great with it, so you can continue to use string with the standard IOStream items. Um, Again, we kind of talked about this before, but let's go ahead and readdress it one more time. If you do CN, if you put a space in, CN will only record up to the space, and nothing behind the space will get pulled in. So if you have if you need spaces, then you definitely want to use getLine as your choice of getting information from the user console. One of the nice things about string is you get to start utilizing a lot more easily operators like greater than, less than. It will return true or false. This is nice. Most of the time, a lot of people want to use it to compare terms if they're similar or the same. Again, when you're comparing strings, it does see case as part of it. So capital George versus lowercase George would not equal the same. Here's a program. Again, this is just an example of some of the things you can do with C string. We know we got to have that C string header. We have some strings we've declared. We're using the get line because we can tell that they're going to have some spaces because we're asking them, hey, put your last name and first name. So we know that there's going to be space there. And now we can use that with the cout. We can also, again, so I'm sorry, in this line we're not using it yet, but we're actually gathering more information. So we're prompting the user, we're using getLine again, and this is where we can start using the cout with the strings. Pretty straightforward, run of the mill. Additional definitions of C plus strings. So when you go to define and create your strings, there are several ways of doing it. You can just declare it, it's an empty object, and then set it later. You can declare it upon initialization. You can use other strings as well as you can put a C string in here and it will convert that to, or it will create a new string for you with a copy of the contents of the C string. This is really cool. You will start to use this at some point, and that is where you're taking this variable, whatever's in this variable, and you're saying, please use the first three characters of that variable. Now, this is significantly different than this a name and verb, right? A name says take the first, start from the very first, and go and do three characters. Where this first variable in verb is where to start based on a zero index and how many characters to gather. So a name is just a neat, quick way of doing verb like this. So you have your verb, your var name, again, no pin, because I am that good. And you, with them saying 3, 2, or excuse me, we're taking this a name and making it into a verb. So because it's 3, we're actually going to say 0, start at 0, and do 3. So, like I said, the a name is just a quick way of doing verb and making that this first var, so the first integer is a 0. No name defines a string and initializes it to 5 A's. So this is the char that you want to essentially duplicate, and how many times you want to duplicate it and make it into a string. Believe it or not, I've used this, and not often, but I have used it. operators, pretty much we've been doing this. You should know these things. I'm not going to go too deep into this. Recognize that these are somewhat mathematical, where these are, and when I say mathematical, like you are inserting into a string, you're assigning, and let me rephrase that. Sorry. So this is more stream based. All right, so you're extracting from a stream or you're putting it in a stream. This is more of the comparison, mathematical comparison. So you're assigning or you're appending or you're concatenating two strings, or in this case, this one you are referencing a character in the string as if it were an array. But again, behind the scenes, it's probably not an array, and so you are, but you can still use it that way. And then this last set is for comparisons when it comes to rational operators that return true or false. Here's an example. Remember, the one thing to take away from this slide is this. So here we are saying CN word 1. And if the user were to enter hot tamale, because we're using CN rather than get line, hot is going to be captured, but because there's a space, this will not get captured. So, as you can see, it's saying hot tamale. Word 1, which is the CN, has hot because it stopped at that space. So if we now concatenate word 1 and word 2, which we put up here is dog, we actually have made phrase say the words hot dog. Now, I was just about to scream foul, but here's that space, by the way. That happened right here. Okay. And then we can take that phrase, and then just like we've done in math with numeric values, we can increment. So this is like saying phrase equals phrase plus this, right? But we can shorten it to the plus equals. And then we can loop through this, as we've talked about, because we're using this, the brackets, square brackets, we could essentially kind of utilize it as if it were an array, and we're going through and looking at each character in this string. Maybe this is a password, and maybe we wanted to pull this out, each character one at a time to check for certain qualities, whether it's is alpha, stuff like that. Another hint. A neat little program kind of showing how to use these things. Take a look at that. In fact, you may want to type this in and play with it a little bit to get a better understanding of all those string functions that we've talked about. So in this slide, they're just letting you know that there are quite a bit of string member functions. So if you have a string, you can utilize all of these different methods, functions. And what this first line is telling you is that these functions are behind a lot of other things, as well as they themselves are also usually have quite a bit of overloaded operators. So make sure you play with some of these, get used to some of these member functions. They usually are pretty self-explanatory. Like that's obviously going to give you the length of your string. You can use this to tell you what the capacity is of your string, and that's going to be based on the current memory. And you can append, you can clear, you can erase, insert, all kinds of things, including doing some compares. Again, some more examples of how to use that. Here we are declaring those strings. We're still using CN, which can be problems because, again, if there's a space, we know that it's going to stop, and so forth and so on. Again, take a look at this, make sure you understand it. If you have any questions, please feel free to shoot me an email. It's It's pretty self-explanatory. And once again, we have another nice little uh, method that they've put together. Well, actually, this is just some code inside the main method to utilize some of those, in this case, only one of those functions. So the length. Uh, oh, good point though. Because we are using a string is a class, and we are setting up the use of something that is a class. When we call these methods that we saw on this previous slide, you are going to have to remember that for most of them, you are going to have this bracket that, excuse me, not bracket, but the parentheses to go behind it because you are calling a method. Some may require a parameter or more than one parameter inside the parentheses. Just remember that you are calling functions. And that is the last slide of this chapter. I'm sure this video is probably a little longer than my normal videos. Who knows? Maybe maybe I'm living in a delusional world and think that my videos are shorter than they are. But the last part was pretty quick. We could get through all of it. Make sure if you don't understand some of these things, do some research out in the Googles. You can find a lot on this. This is very standard C++ um, language language items that you can just find a plethora of information on it. Make sure you are playing with it and doing some tests. If you have a question, try it out first. Make sure like we did earlier, where hey, what happens if you try to shove this C string into a C string that's not big enough? What's going to happen? Well, before you shoot me that email, go out to your online compiler or your Visual Studio and try it out. See what happens. Oftentimes you'll remember the results of that a lot better than if I just give you the answers. If at some point you can't find the answer, you feel free to shoot me a message and I will get that answer for you. All right, that is chapter 10. Thanks, and we'll see you soon.